In this tutorial, we are going to dilate an object on the coordinate plane. To dilate an object means to enlarge the size of an object or to reduce the size of an object. The scale factor will determine how much larger or smaller the object will become. A scale factor greater than 1 means the object will increase in size. A scale factor less than 1 means the object will decrease in size. Because any value less than 1 is part of a whole or a fraction, the dilated object with a scale factor less than 1 means the new object will be a fraction of its original size. Also, a dilated image will always be similar to its original. Where the dilated object is drawn will not only depend on the scale factor, but also where the center of dilation is located. When corresponding points of the original and dilated figures are connected by straight lines, the single point where all of the lines meet will be the center of dilation. The center of dilation may be the origin, or it may be another point such as a vertex of the original shape or any other point located on the coordinate plane. The first example of dilation that we are going to demonstrate today is when the center of dilation of our object is the origin. We are going to dilate the triangle shown, triangle ABC, by a scale factor of 2. Because the scale factor given is greater than 1, we automatically know that our shape will increase in its size. If the center of dilation is the origin, simply multiply all the coordinates of the original shape by the scale factor given. First, we should make sure to write down all of the coordinates of our original shape. After writing all of the coordinates of your original shape, simply multiply all of those numbers by a value of 2. First, I am going to multiply all of our x values by a scale factor of 2. So if we double all of these values, 4, 6, and 8, we get the new values 8, 12, and 16. Now we are going to increase the y values by a scale factor of 2 as well. So I'm going to take the values 4, 8, and 4 and double those, which will give us the values 8, 16, and 8. Now we have the new coordinates of our dilated object. Simply find those coordinates, plot the points, and connect them with a straight edge. To check the accuracy of your dilation, simply take a straight edge and connect all corresponding points and see if that line were extended if it would intersect at the origin. With this example, we can see if we were to connect a line with point A to the other point A and extend that line, it would indeed intersect at the origin. And the same is true for the corresponding points for B as well as the points for C. Another thing that you should notice is that if you were to compare the distance from the origin to the original points given as compared to the distance from the origin to the dilated points, all of the distances should have doubled because the scale factor was increased by 2. For example, compare the red line, which is the distance from the origin to point C, as compared to the distance from the origin to the dilated point C, which is shown in green. We can visibly see that the distance from the origin to the dilated point C was doubled from the original location of C, because the image was dilated by a scale factor of 2. The same will be true for all of the other corresponding lines.